I'm going to walk you through today the first couple steps for our Unit 2 project. So I've made some updates this week to make things easier for the search, for the downloading or sideloading the data into Galaxy, and also for how to search for your hypothesis and get some ideas of what could change between these two samples. So the first thing I'm going to do is pick a topic. And I've put together a spreadsheet that is all of the typical questions that you'd see in an American Gut Project sample data. So the metadata for the American Gut Project, they usually ask all of these questions. There are more questions than this for individual collections, and you're welcome to use those too, but this is some place to get started. So if I look at appendix removed, because this is the example that I used in the assignment, I can see that the potential answers are true or false. Once I have that, I'm going to click on the choose your topic and write my topic down so I can claim it. Everybody in our class has to do a different topic. And I can use this, the question and the expected value, to do a search on NCBI biosample. So I'll show you how that works. I'm going to do quotes. Probably the smartest thing to do is to actually copy the text. See how it has an underscore. I wouldn't get anything if I put a space there, and then look for true. And I can find that there are 1,658 individuals who answered true to that question. And I can search for false, and I can see there's 14,000 samples where someone answered false to that question. So lots of really good choices. That's how I'm going to get my sample information. And from this, I can directly click on the short read archive. This is where the raw data is stored to get the ERR number and the number of reads. So if I scroll down here, I can see the ERR number appears right here. And then the number of reads is the number of spots. I can get the data in two ways. I can copy that ERR number to the European Nucleotide Archive, and we're going to the second place because not all the samples on NCBI store the quality information, and we're going to need the quality information for the next step. And then I would click on this fastq.gz, so it's a compressed fastq file, to download it. I can also take that information and put it into an app called fastqdl on Galaxy and run the tool. When I run the tool, I won't need to keep the paired end data or the metafile data. I could delete those, and I can name my history unit 2. While that's running, we can look at some of the next things that we're going to look for in our first assignment, which is we know how to get the ERR. We know how to look at the number of reads or number of spots. It shows up here on SRA. It shows up here on read count on the European Nucleotide Archive. And now we just have to make a hypothesis. So what would a hypothesis look like? Well, probably we want to go to the literature and see what people have studied about this particular survey question and the gut microbiome. So we could look up appendectomy, gut microbiome. And you'll see lots of different articles. Altered gut microbiome by appendectomy, all these different things could give us a hypothesis. And the article that I found was this one from 2021. And in this article, they looked at people who had not had an appendectomy, the control, and found that they had more of this Ruminococcus genus. So that's basically the whole number of things that you need. Most of this information, the read number, the ERR, and even the hypothesis you can get from NCBI. Once your European nucleotide data has loaded, you can delete collection and elements for those two sets, and you can rename it. No appendix fastq. and now you're ready to run the next steps.